Welcome to JuiceBox.org. JuiceBox helps energy companies, consumers, and experts examine energy alternatives. For this exercise, we have created a simplified version of Wisconsin's electricity system. While Wisconsin has well over 100 power plant locations, we have consolidated these by fuel type into a handful of virtual power plants. We'd like you to design a realistic future electricity system that meets three criteria. First, it must provide reliable electricity. In other words, keep the lights on. Secondly, your plant should be clean. In this case, it should stabilize carbon dioxide emissions. Finally, your plant should keep electricity affordable. You'll see color-coded map icons for each power plant location. The fuel-specific icon colors correspond to the graphs below. I'm going to increase the graphing panel and select the Solve button. The generation graph illustrates the resulting fuel mix, electricity generated by each power plant throughout the planning horizon. Renewables are shown in green, nuclear in yellow, coal in gray, natural gas in red, and diesel in black. This overall mix of resources used will determine how much electricity costs, as well as the resulting emissions. The first job for an electricity planner is to keep the lights on, so let's look at the peak capacity graph. It shows the total capacity of available power plants for meeting peak electricity demands in the summer. The dashed red line represents the annual peak electricity demand, plus an additional 15% buffer that's intended to minimize the risk of a summer blackout. We are assuming that peak electricity demands will grow by 2% each year. The compliance bar changes from red to green in 2016, indicating a shortage, where our available capacity falls below the dashed red target. Let's add new power supply to meet future electricity demand. To do so, I'll set the timeline slider to 2016. Then I'll select the Build button, the hammer and wrench in the upper right-hand corner. Notice that there are many different kinds of power plants and also an option to save energy. From the list of prototypes, I'll choose the natural gas combined cycle technology. I'll adjust the quantity to 2,000 megawatts and select Add Plant. Notice that an icon for this instruction appears on the timeline. I'll repeat these steps again in 2020. When I resolve, notice that the colored compliance bar and graphing button have changed from red to green, indicating that I have added enough capacity to meet summer electricity demand. Looking again at the generation graph, we see that electricity consumption is increasing, as is reliance on coal and natural gas. JuiceBox uses a power sector model that estimates the most cost-effective use of resources. Different power plants have different costs to build, to operate, and for fuel. Coal is inexpensive and is therefore highly utilized. The average rate graph shows the cost for electricity, the average cents per kilowatt hour for electricity generation, transmission, and distribution. The red line on this graphic sets a cost target to keep electricity prices less than 12 cents per kilowatt hour. Electricity will become increasingly expensive as you increase energy supply. The average cost of electricity will depend on the types of power plants that you add. Carbon dioxide emissions will also depend on your choice of energy resources, shown on the CO2 graph. Using coal, natural gas, or diesel will contribute to carbon dioxide emissions. As shown by the red target line on this graph, your goal is to levelize CO2 emissions over the last 5 years of the simulation. That means lowering the emissions shown on this graph below the red target line. Let's modify our plan to lower CO2 emissions. To change an instruction, select the corresponding icon from the timeline and then select Edit Construction. From this dialog box, I can delete the instruction or modify the quantity or year of construction. I'll decrease the quantity of new natural gas power by 800 megawatts. Next, I'll add 800 megawatts of wind turbines in its place. When I resolve, we see that CO2 emissions have decreased slightly, but not enough to meet the CO2 target. We also see that the capacity graph button has changed from green to red. Looking at this graph, we see that we no longer satisfy the capacity requirement after 2023. The wind turbines have lower emissions, but also lower availability during periods of highest summer electricity demands. This is an example of a trade-off. As you work with JuiceBox to meet the emissions target, you will see how different combinations of power plants affect reliability, cost, and emissions. I hope you enjoy testing many different strategies for clean, reliable, and affordable electricity.